Hey, welcome to this presentation from our workshop for data labs. My name is Erik Borälv and I'm on the team for Vinnova's data labs. So a few words about Vinnova and the data labs itself. So Vinnova is the Swedish innovation agency. We provide funding for innovation projects in all areas, you could say. We cover innovation high and low, you could say from space to mining. One of the recent global changes that's happened is the digital transformation, and this change is of course fueled by the increased amount of data. So this is happening in all sectors, and this can especially be observed by the many news articles around data, which is also fueled by this data transformation. So in order to help this transformation to happen in all areas, Vinnova has funded data labs through 3 open calls. At the moment, we have 16 data labs in areas such as health, space data, the Swedish language, about the forest, about real estate, just to name a few. So today's presentation is part of an internal workshop for our data labs. All of our data labs meet twice a year. Now online, of course, to report progress, but also to talk about challenges. And challenges could be, for example, developing data factories or sharing platforms for data where users interested in those kinds of data can access data and develop their own innovations. So in a minute, we will hear a presentation from one of our data labs. It's done by Marcus Liwicki. He is a professor in machine learning at Luleå University of Technology. He will introduce himself very shortly. We will also open up for questions during the presentation and talk about those after the presentation. So please use Menti and the code displayed on the screen. So welcome, Professor Liwicki.
Much for this nice introduction. And thank you very much to Vinnova to giving me this opportunity to speak here at the end of this conference, but also to a broader public. I will speak today about the process from data to innovation, and also how AI and machine learning is involved in Swedish data labs. First, let me give a short motivation. The main message of my presentation is that data alone is not enough, and I want to give here the analogy to oil. Maybe you have read this article or you have heard data to oil. The original is that data is the most valuable source nowadays. But this data alone does not really help us for everything we want to solve. We need to use it we need it provided for our usages. It's similar with oil. So I guess that not many of you bought barrels of oil in the last year, but you used oil in many of your applications during your everyday life, when we're driving, when we want to heat our house, or just buy plastic. So what's in between this barrel of oil and our everyday life end products? There are processes, for example, and the most important first process is oil refinery, which makes the oil processable and useful for their various applications. And that's the same with data. If we would just have data, it is like on a big heap, unsorted and very difficult to find what we are actually looking for. And for our end applications, we will have directly that data which we want to use in this domain for this specific application idea. And we need intelligent infrastructures in between, which help us to find the information and the right data we are looking for our applications. And that is what the data labs are. Ensure that the data is ready for use in the applications. And that is like a short outline of a presentation today. As Erik said, I will shortly introduce myself and also our machine learning group here in Luleå. Then I will speak about what data labs are from various perspectives. And I will speak about AI and machine learning in data labs. And I want to highlight, we had already now this 2 days workshop, and there were some quotes which I remembered, some people said, we do not use much machine learning, very simple methods like regression worked already very well. Or others even say AI isn't really needed, just the rules are working already. And that makes me aware that we have to really define what AI and machine learning is about. And then I will speak also about how these and where these methods are integrated in space data labs. And particularly, I will focus on the Swedish Space Datalab, where we are part of it, analyzing satellite images for various use case applications. And I will show you then where AI methods are used. And then I will give an outlook to future perspectives. So a brief history about myself. I will not go through all in detail. I have been working on neural networks already since 2001, and doing my PhD studies already quite early, more than 10 years ago, was working in the area of deep learning in Switzerland, and I had also the luck that I could work together with Jürgen Schmidhuber. And then I worked on various applied AI research areas, for example, in the German Research Center for AI, but I also had some stays in Japan and Switzerland. And finally, for 2 years now, I'm here in Sweden, chair professor in machine learning. And our group here has like 3 major tiers. One is in the fundamental machine learning research, trying to understand neural networks and the human mind. And application-oriented research, looking how we can use machine learning for the welfare of the society. And finally, even having application research in our lab. For example, science, technology, engineering, and math education combined with arts, here music. In some European projects, we are working also on historical document analysis, of course on space data, but also on data in the mining industry. And our group is rather young, as I said, just, a bit like 1.5 years that the people started working in our group. We have 10 people who are already with us, and 10 more will be coming this year. And as a quite interesting matter of fact, so far we have a quite nice quota of 40% women. So it's possible in computer science and machine learning that there are also many women working in this technical field. And our main theme applied for the people, with the people. Okay. But now coming back to the data labs, I already gave a motivation that data labs are important to make the data really useful for the end applications. And I want to zoom in a little bit more into that, what that means. If you look, for example, on what Vinnova defines what data labs are, like it was also written in their call, the data labs are there to create the specific domains, to ensure that the data is available, and the best would be that it's even freely used and accessible for anyone interested in the data. And it has to be enabled for usage, and Vinnova says, for example, for usage of AI. And it should facilitate data-driven organizations without the hazard of curating the data for every single application. And to give it a bit more higher perspective, so what the data lab is for is taking this heap of data and making it available for researchers to analyze higher level questions. So when we look at the satellite data, for example, the researchers are not interested in looking into every individual image and counting the number of bears or whales or seeing how many crops are in the field. No, they are more interested in higher level questions like how did the process of the population of bears develop, or change in the last years, or how did the vegetation change in the last years? And I will come to particular applications a bit later. Then also applications for end users who want to use the data, like a farmer on the field, to see where are fields more fertile, where it might be useful to apply some fertilizers and so on. Or mid-level services. These are services which are provided where the data is already curated, but then the way how it's finally used can be adapted by application developers like smaller or medium-sized companies, or also governmental agencies who want to use the data for some internal processing for their final questions. So we want to make the data not only accessible, but also actionable. Good. Now, as I said, I want to speak a little bit about machine learning and AI in the data labs. I think it's necessary just to agree in every AI-related presentation on what we really mean with AI. I take the very broad definition of what is AI, and this means an AI is an agent, an artificial, it could be software or embodied hardware, which interacts with an environment, and the environment can be virtual or can be the physical environment. And the agent perceives information from the environment, has some processes inside, and then takes action and interacts with the environment. And this definition is not new, it's actually already quite old. It was used by Russell and Norvig back in 1995, but it's also used nowadays by the European high-level expert group on AI, which is just a report dating 1.5 years back. So it is a very recent definition of AI, and we could look into the full text what AI actually is. And it's mainly systems designed by humans that act in a physical or digital dimension by perceiving, as I said already. And as you see here, some words like it can work with collected, structured or unstructured data. It can reasoning on the knowledge or processing the information derived on this data. So it's, in short, tries to perform the best actions to its a given goal. This is what AI is trying to do. And there are three major research areas in AI. One is robotics. There, the agents try to really interact with real environments. And robotics involves also sensors, actors, and other areas which are not only computer science. Then it also involves reasoning and information retrieval. So when we want to try to infer answers based on given rules and facts, or when we want to find something like Google search, that's also AI. And machine learning, finally, that's currently very much in a hype. So when we are presented with data, then the systems want to improve their performance. And deep learning is currently the major hype term, and I will come to that also in a small moment. Then, just as a summary of the slide, even the simple rules in reasoning and retrieval of facts, they are also rules based on facts. They are also AI. Good. And some related fields, which we often hear when we speak about AI, is data science. This involves machine learning, intelligent systems, statistics, and visualization, but also computer science is a related field, which is also about how to program, how to make a good user interface, and so on. And here's a summary. If we put these definitions of AI and machine learning, robotics, and so on in relation to the data labs, I would say the data labs, they should be the optimal data science approach for the envisaged target domain. shedding a bit more light into what machine learning is, I think most of you are aware of that, but very briefly, I want to just summarize that again. Machine learning is inspired by human learning, the process that a computer learns to recognize symbols, images, text, whatsoever, and acts maybe as intelligent as a human would do. And a very typical method is, for example, neural networks, which is really trying to simulate the neural behavior as in the human brain. And there are two areas of machine learning. One is supervised machine learning. That is, we are given the image, for example, but also the labels. We say, this is a cat, this is a cat, dog, and the machine learns on these examples. And then there is unsupervised learning, where we just have a lot of data, and that's very often the case. We have a lot of data, but it's not curated. We do not have labels. It's actually just a heap of data, but still the machine can search some common pattern in this data and maybe identify, hey, there are some things similar. A human can look into that and say, yeah, these kind of things, they are probably all cats. And this gives us here also an answer. Not only deep learning is machine learning, but actually also clustering or simple methods like regression, they are also machine learning. And when it then comes towards deep learning, which is currently the big hype, it is not just recognizing very simple patterns like characters, but more complex things like words, or even being able to understand complete sentences. And this is currently one of the most complex tasks machine learning can solve with deep learning methods, mainly deep structures, deep neural networks. And they are able to understand, finding out that it's speaking about cities maybe, and organization, and maybe even the names of the organization and so on. And why is deep learning mainstream only now? It is because we have some advanced algorithm, but it's also mainly because we have large data sets and we have a lot of computational power. And that these are some of the major enablers for deep learning at the moment. Today I will not present more about AI and machine learning, but for that there are various courses online if you're curious to learn more about that. For example, there is on AI Competence SE, there is a huge collection of courses. Also LTU offers a 7.5 credits course, a real free movers course, as we call it in English. So it's a course electable by anyone living in the EU who would like to listen to that course. And we run it every half year, and currently it's open for late application. So if you're willing to learn more, you can maybe register for that course. And there are also shorter courses. For example, there is a nice course which is like a blog, which is called Elements of AI. Maybe some of you have heard it. They also have a Swedish version. And there's a nice podcast course on AI, which is interesting for those who like to listen to podcasts. And there are many other resources, as I said already, on AI Competence SE you can find. Coming now to AI and machine learning in data labs, which is like the major topic of this presentation here. First, my very humble message here is, yes, in most of the data labs, there is really a lot of deep learning involved, but only one part of the puzzle. We can also apply simple rules, like just apply simple reasoning. We can use basic machine learning methods like regression and clustering, and sometimes just statistical methods. But all of these is also AI as a whole, and thinking about how the computer can intelligently help accessing and processing the data that we can finally use it. That is actually already quite a bit of AI involved in this process. And as an example, I want to speak here about the Swedish Datalab, the Swedish Space Datalab, where I show where AI is used. We are dealing here with space data, and if I show you an image here, you can say, oh yeah, that's one others to understand here probably some areas with no vegetation, and here is quite a lot of vegetation, and here is probably sea, ocean. But if I show you now the same region a few days later, you see, okay, maybe it's not always just the color which is showing us the information we are interested in. And sometimes we have the problems of clouds and shadows of the clouds. So it's very straightforward to process and label these kind of images. And the Space Data Lab is there to help us doing some of the low-level data processing that for final applications we can use it. And this can be depicted in this kind of diagram. So we have the unprocessed satellite data, which is in. It's already then processed on various levels. Come to that in a minute. Then we have an open data cube, which is a non-profit open source data factory, which is giving us, providing the data for various use cases, for analysis, where analysis methods are developed in research, and maybe for applications where we have some end application, which may be also a user interface, a very useful user interface where users are not really dealing with the original space data, but more with a view which is intuitive for them. Or we are providing the data also for service, where companies can then develop their own application processes, business intelligence, and users interfaces to use that data. So the Space Data Lab fulfills these requirements of making data available for research, for application, and also for services. And now is the question, where is the AI? If you remember, the original definition was the data labs should make the data available that it can be useful also for AI. The interesting thing is actually that the AI processes is already involved in all of the stages. There are already AI processes. So for example, when we have the data from the data useful data, already image processing technology, labeling and classification approaches, and I will show some examples in the next slides. Then when it comes to the open data cube, there's also some of a raw satellite image which gives us a region, this mapping to the geospatial coordinates and mapping of various images, stitching them together to have a uniform map and so on. There's quite a bit of AI technology also involved to do some advanced labeling, which can tell us, hey, where are forests, where are lakes, where is snow? These kind of things are also handled by AI methods. And then also maybe some higher level forecasting, saying how did the vegetation evolve over time. These kind of things can be also provided directly by the data cube, and they are provided in our Swedish Space Datalab. And then, of course, this process data is also available for further analysis. And in all of these three stages, in analysis and applications, but also in services, there can be AI methods involved as well. For example, application-oriented AI methods which try to forecast future behavior, or which try to forecast the fertility of a specific area when it comes to crop the fertilities for various crops or fields and so on. Or we have maybe some decision-making processes which take the information, how did the vegetation develop over the past, in order to say, oh, now we have to act, we have to, maybe water areas, or we have to change the local industries in an area or whatsoever to address and counterfight these problems. And there are many, many other opportunities where AI is possibly involved. The Swedish Space Datalab, just as an information of a background, it's a collaboration of various partners like Luleå University and RISE as research institutes. Then we have AI Innovation Major Coordinator. We have some governmental agencies involved, and of course we are funded by Vinnova. And some of the already existing outcomes of this project is that we have open data available, or we use actually already a source of open data, which is a Copernicus data, and we process it further with intelligent processes to make it useful for Swedish use cases, which I will also show in a moment. And we will build on open like DataCube, and we are providing open source code for working with the data for specific examples. So these two examples which I'm showing you now, we have online Jupyter source code scripts. Currently, they are yet accessible for people registered in the Open DataCube, but they will be all available freely online, these sample scripts, till the end of the project. Just an overview of the Copernicus data. So the Copernicus data is based on various sections of a huge size, and they are grouped as Sentinel-1 and 3, and they have different levels of detail and so on, and there are also different processing stages. So you can have either the raw data, or already the Copernicus data makes a rough analysis. What is maybe urban area, what is not urban area, and what are maybe water areas and so on. And typically you have a new data here in Sweden every 4 days. So it's not every day, but still rather often when you get new data. And when it comes, for example, for land cover classification, we have the original satellite image, and then we are interested into where, for example, water is vegetation, and maybe where non-vegetarian areas. Some of you know where this area is. Then for doing that, already AI is used, so-called convolutional neural networks, which is a specific deep learning techniques. And I will just give a short idea how these work. So originally, convolutional neural networks were used for labeling when it comes to street images. So you have an image input, you want to know in the image a car, there's a road, some students, we wrote mark, maybe some trees, and so on. Then one goes over the image. So you have the image as an input, and then you go with a filter over the image, and at every position you process this data and you learn these filters automatically. And then once we have kind of meta information learned, we try to use this to label the images according to regions, like street and street markings and cars. And what the network needs to learn is various images and the example labels for every pixel in this image. It learns automatically to adjust, and then it can be applied to other street images as well. And this kind of technique can also be used for satellite images. So we give it as an example various satellite images, and corresponding expected levels, like here is non-vegetarian, here is vegetated, and so on. And then the network will learn to classify this, and then we can apply this network on many, many billions of images. And this kind of process data can be then used for identifying drought. So when we want to, for example, find out how healthy the vegetation is in some area, we can analyze the normalized difference area, which is called NDVI. This is can be derived from the satellite imagery data. And here are some example images, how it looks like. So when you give an input image here, this is this blue input, bluely marked image. When you give that as an input, it will tell you where are many trees, where is a lot of vegetation, there is no vegetation, and sometimes you will also have clouds which will include parts of the image. And this kind of labeling was already trained beforehand and is quite accessible. But what kind of higher level research question is then interesting is if we have now the labeled images for various timestamps. Here, example, area during the big drought in 2018, where there were also many fires. We can see how the vegetation developed, and there was a lot of vegetation, and sometimes you have clouds, of course, occurring, but sometimes there's also less. And see a bit how things evolve. We can ask the higher level question, is the development of the vegetation in this year normal or not? And for that, we use AI. It's a Gaussian Process Regression. And I will not go into the detail of how this method exactly works like, but one can look into a normal year when you have the vegetation, and one see that vegetation is growing and quite stable over several months. In the year 2018, the vegetation strongly down because there's a lot or not enough humidity. Was quite a big drought in that year. And if we have the data available from various years, we can use it to analyze the process, and we can see here this blue behavior is different from what we normally would expect to see. And we do not have to look into all individual images and trying to understand it, but we can directly look into the data which is processed by the Swedish Space Datalab on a bit higher level. And similar use cases you can see, like how is the development of industrial or urban areas happening over years, and how is the water level, and various other use cases are applicable. Good. After this short overview of the Swedish Space Datalab, I will give just some future perspective for data labs in general, but also for the Swedish Datalab. So in general for data labs, this workshop the last 2 days was a quite successful event. It shows us not only that the data labs individually are maturing and trying to really fulfill all the intended rules for research applications, but also for services. But the good thing here is that we also have a joint improvement, that all the data labs benefit from one another. So we have quite a bit of collaboration, where every data lab speaks about their recent progress and what they have used and what was useful and was not. And there is an intention and the idea to have maybe a common place for sharing the best practices, to learn from one another, and maybe in the future also have a joint technical infrastructure where Swedish data labs can all work on also future data labs. And that is not only something interesting for Vinnova and the Swedish Space Datalabs, but also in general for AI in Sweden. I'm also part of the Swedish AI agenda group, which is trying to suggest for the politics future important developments when it comes to AI and the investments which should be done. And there needs to be a good investment in a joint technical infrastructure to have data labs really working sustainably. And in terms of future research, and interest question is, can we accelerate this process of creating data labs? Every data lab at the moment has some problems in the starting before it really become running. It would be good that this would be expected in the future and maybe even automated, where only human experts are required sometimes in a human in the loop approach. For the Swedish Space Datalab, there we are expanding the areas of analysis. Currently we look mainly in the Vänern region, and for some use cases interesting there. And we want to also look into some special cases which are very relevant here in Sweden. For example, classification snow versus cloud. There are not really good machine learning approaches available, or maybe analyzing the thickness of ice. And we are also planning a hackathon. Actually, as a matter of fact, there was a hackathon planned just around these days now. Unfortunately, because of Corona, that's delayed until autumn, and you will see information on the website of the Swedish Space Datalab. And finally, we are linking also to another very interesting project going on in Luleå University, which is called a Global Wedge. It's a collaboration of various stakeholders. And the idea is to understand the state of our planet and get a good recognized situation picture. And of course, that's very interesting also for climate change, but for various UN sustainability goals. And such a collaboration between the Swedish Space Datalab and the Global Wedge Center can lead to a European Space Digital Innovation Hub. And that's an idea which we are currently working on, and maybe we will become one of them in the near future. That's all from my side. Thank you very much. Thanks to my colleagues and all the partners of the Swedish Space Datalab. Thank you.
So thank you very much, Professor Liwicki. We have seen a few questions. I will try to read them to you. So is there a difference between machine learning and data mining?
The question is there a difference between machine learning and data mining? Yes, there is a difference. Actually, these two concepts, it's like two big concepts with scope over various areas, and they have a big intersection as well. So they are overlapping, but they are quite different from one another. So machine learning concerns when we have supervised or unsupervised machine learning. As I said already, there's clustering. When we have labeled data, we can maybe learn on the labeled data to improve for the future. While data mining is when we have data available, we want to understand patterns, find patterns in the data. And typically, maybe the data is not labeled yet, and we want to find the labels by clustering and so on. And there are different views, actually. So most people in the data mining community, they would say that data mining is about everything when it concerns the data. When it comes to, it's called the Chris data mining circle, where you analyze and understand the data and so on. All this is not part of machine learning, but this is part of the data mining circle. And machine learning is maybe one method which can be used in data mining. From a machine learning perspective, many people would say machine learning is a very broad research field where it also comes to reinforcement learning and self-adaptable systems and so on, which are not really needed for data mining. And data mining is just one possible application of machine learning.
Okay, so there was a question about, so today we have lots of space data. It's a little bit complicated and vast amounts. So how about making data and space data actionable and human in the loop you talked also about? So yeah. What are the enablers and barriers for making that happen, also for non-researchers and that kind of discussion? Mm-hmm. How do we make that actionable?
Yes, very good question. And it's very much relating to Okay, sorry, I have a delay in my presentation here now. Coming. Somehow it's not really, yeah. It's related to that slide here, but it is not staying. So we have a satellite data, and as you said, there is a lot of data, and we also in our Space Data Lab project, we had like the problem. It sounded like, okay, Copernicus data, that's available, very easily accessible, we can directly use it. No, it's not so easy. Needs a lot of processing to make it mapping to the Swedish map, to make it aligned to each another, to one another, to have the overlapping areas stitched correctly together and so on. The process is almost solved now. And we are not yet rolling it out for the general public because there are still some scalability issues, and we are not accessing all the Copernicus data yet because we have to integrate that all into our interface. But we had already a hackathon back in January where we used some of that data. And there were more than 100 participants, and we have seen that it worked quite well, that they could really use the data for some specific, when it was mainly about image analysis or drought or NDVI analysis. For these kind of use cases, it's worked already quite well. And the major challenges here really these making the right interface between these different data sets which are available in this Copernicus cloud, making it all useful in one interface which is easily addressable by the different applications. And the second challenge is it's quite a lot of data. And for that, luckily, we have the RISE data center infrastructure here, RISE 6 ICE up in Luleå, which is the most energy efficient data center in the world. And with that one, we have a good space or place where the data is actually physically stored.
In the middle now of the corona crisis.
I did not hear the beginning of your question.
So we are now in the middle of the corona crisis, and we hear the news that some countries have vastly improved environment. The air quality has improved. Does this affect satellite processing? Does it improve your data?
That's quite interesting. We spoke here about the different stages where AI is used. And since our methods are quite generic, we can say that the parts which concern our Space Data Lab itself, when it comes to the sorry, I'm hoping my pointer is coming back, but somehow I have a big technical. No, it's coming. Okay. So we are at the processing, at the image processing stage. These methods, they work in various regions all around the world and have been trained on vast domains of data. So they do not need to be adapted now with the climate change. They will work rather well on that levels. But when it comes later to the application-oriented AI, we will see quite big differences when it comes to the analysis of that data. And these are not really concerning our data lab, but then the specific use cases at hand. So our data lab would be general enough to work also with a new kind of satellite data, but for the applications at the end, we will see differences in the outcomes. one can imagine then, depending on the different use cases in mind, you will have then different observations than in the past.
So maybe one last question. So in the beginning, and maybe still today, we talk about some kind of macro analysis, that we look at the big picture, we look at the environment, the sea, the forest, and so on. With increased technology and more satellites and increased resolution, will the domain of space data change when we get more and more detail? Will we sort of be talking about individuals and movement patterns and people also when we talk about satellite data?
Well, that is a quite interesting question, and just the last point which you gave here could even raise some ethical concerns. And then if you think about some American futuristic series where all of these is kind of automatically processed and so on, I wouldn't say it's impossible. I think it would be possible if we have high resolution data, specifically maybe focused on some cities, to have a good micro-analysis for these use cases as well. But that's not something which is on my personal research agenda, and also not in my real interest to go into that. But there are actually this better improved data will help us in the macro and in the micro analysis. So in the micro analysis is quite obvious, and already nowadays used. I'm quite good in the area of agriculture because we have a PhD in that area. She is looking into agricultural data, and we realize not only how fertile is a field, or which of the three major regions in the field, but really for every few square meters, it's a resolution maybe of 20 square meters, knowing what are the good and what are the not so good areas. And that, combined with vehicle technologies, can help us really a lot in the micro analysis. But these outcomes can also give us better estimates for the macro analysis. For example, we can then analyze which fields are more homogeneous, which are more heterogeneous, or if we are looking into wildlife population, like detecting whales, that's currently in the Ocean Datalab, an example. There we then can analyze how the population changes, because we really can identify every individual whale. So it helps us in the micro and in the macro analysis. And there are possible scenarios of using this kind of satellite data also for the surveillance or observation of maybe humans or populations of some species. But that's then very use case specific, and the stakeholder in that use case area has to decide in which directions to go with these kind of methodologies.
So maybe one final question about IP and openness. So space data today is mostly open, and you work in an open fashion. So where do you see this going? Will space data solutions maintain open, or will it also be a closed business model for the future?
Most of the low-level processes will be open and remain open as they are already now. But some adjusted high-level processes require quite a bit of energy to compute, or quite a bit of methods to be researched on and improved. For that, there will be then some business models for SMEs, also, and SMEs involved, small, medium enterprises, which are involved in our projects or among our partners. And that part of the process data would be not freely accessible for everyone.
Okay, so thank you very much, Professor Liwicki, for your presentation and answers to the questions. So thank you also for all listeners to this broadcast. Thank you very much, and goodbye.